Our project is based around a tabletop labyrinth game made by Brio that involves leading a steel ball through a maze with holes in it, using the dials on the sides of the board to change the tilt in both the X and Y direction. The project is generally split into three categories: the computer vision, the motor control, and the ball control. The computer vision consists of initially taking a picture of the board from above and using hue, saturation, and value to draw contours of where the walls and holes are. This will help us avoid dangerous areas for the ball to go. We then use edge detection to detect the guiding line that leads through the course, and with this line we can then place nodes along the course where the ball should find itself on the way to the final objective. With a path now found, the visual portion of the project focuses on updating where the ball is at any current moment and where it should be headed. As you will see later in the video, we have added the ability to click anywhere in the camera frame and have the board move the ball to that location.
A wall adapter is used to power the motors and H-bridge. The H-bridge is used to control the speed and direction of the motors. The motors have encoders on them to determine when the motor is turning. The amount the motor is turning is then counted using two counter chips and sent to our microcontroller to be used in the motor controller. The motor controller is given a desired angle we want the motors to turn to and the current angle of the motor, and is used to determine how fast and what direction the motor needs to turn to get to the desired angle. The desired angle is received from our ball controller, and the current angle is received from the counter chips that we used. The ball controller is used to determine how far the board needs to tilt in each direction to move the ball to the correct position. The controller receives two pieces of information from the computer vision. It first receives the desired position on the board that we need the ball to move to. This position is determined from our game logic code and is updated to the next desired position each time the ball reaches the previous desired position until the ball has made it all the way through the board. The second piece of information it receives is the current position of the ball. The camera is constantly tracking the ball, and as the actual position of the ball gets closer to the desired position, the board tilts less and less until the ball settles in the correct position. These two pieces of information put into the ball controller create an angle for the board to tilt in each direction, and this angle is then sent to the motor controller to determine how far the motors need to turn to reach the correct board angle.
What you're seeing now is the final state of our project. It's currently displaying ball and plate mechanics, which is where the user clicks in the camera frame where they want the ball to go, and the plate attempts to move the ball to that location and hold it in place.